Hi, I'm Dr. Incognito. In this video, we're going to calculate definite integrals using the fundamental theorem of calculus. So the general problem is to compute the integral from a to b of f of x dx. And this is accomplished in a two-step process. Step one is we have to find an antiderivative of the function f of x. And we'll call that function capital F of x. And the second step is to plug in the numbers a and b. So that's what this evaluation bar means. So this is equal to capital F of b minus capital F of a. And this result is known as the fundamental theorem of calculus. So let's look at a few examples. Let's calculate the integral from 0 to 4 of the square root of x dx. First, we need to calculate an antiderivative of the square root of x. To do that, we will use the power rule. To use the power rule, I will rewrite the function square root of x as x to the power 1/2. Now the power rule says to anti-differentiate x to a power, we should add 1 to the power and then divide by that new power. So here, instead of dividing by the fraction 3/2, I will multiply by its reciprocal 2/3. So this is an antiderivative of x to the 1/2. You can check it by using the power rule. If you bring down the 3/2, it'll cancel with the 2/3. Subtract 1 from the 3/2, and you'll get x to the 1/2. So that's f of x. Now we have to remind ourselves to plug in the numbers 0 and 4 to complete step 1. And now in step 2, we plug the numbers in. The top number goes first, and then minus the bottom number. So 2/3 times 4 to the 3/2 minus 2/3 times 0 to the 3/2. 0 to the 3/2 is 0, times 2/3 is 0, so this term is 0. And meanwhile, 4 to the power 3/2 means take the square root of 4, which is 2, and then raise that to the third power, which is 8. So we have 2/3 times 8, which can be rewritten as 16/3. So the value of the definite integral is 16/3. In our next example, we will look at the integral from -2 to -1 of the function 1 over x dx. For this problem, finding the antiderivative, the power rule does not work. If you tried integrating 1 over x as x to the -1 using the power rule, you would get x to the 0 divided by 0, and this is undefined because of the division by 0. But fortunately, we know a function whose derivative is 1 over x, and a simple answer is log x. But the best answer is log of absolute value of x. The log of the absolute value of x has as its derivative 1 over x. And this function allows for negative inputs, which is especially important in this particular problem because my end points of integration are negative. So I have the log of the absolute value of -1 minus the log of the absolute value of -2. So here we can see that the absolute values are crucial because without them, the log of -1 is undefined, as is the log of -2. But now it becomes the log of 1 minus the log of 2. The log of 1 is 0, so this is negative log of 2. So there is our numerical answer. The next example, integral 1 to 3 of 1 over x squared dx. So for this one, we do use the power rule and not the log rule here. This one can be rewritten as x to the -2, and then we can apply the power rule, x to the -1 over -1 from 1 to 3, and this antiderivative simplifies to -1 over x from 1 to 3. So we plug in 3, and we get plus 1, which is 2/3. I would like to revisit this last computation I'm going to do it in another way that gets the same answer, but without quite so many negative signs. So going back to here, what we can do is we can get rid of this negative and just write 1 over x if we switch the order in which we're going to plug in the numbers, because switching the order of a subtraction will generate a negative. So put the 3 at the bottom and the 1 at the top. And now it becomes 1 over 1 minus 1 over 3, which is a lot cleaner than this one. And that is 2/3. So it is the same answer, of course. And that's a nice way to deal with an antiderivative that has a factor of -1. You can simply erase the negative and switch the numbers. I'm going to look at another example now where we're going to want to do that. There would be even more negative signs. Let's look at the integral from 3 pi over 4 to pi of sine x dx. So the antiderivative of sine is negative cosine x. And then, since we have that negative there, we can rewrite this as cosine x and switch the numbers pi and 3 pi over 4, so that we get cosine of 3 pi over 4 minus cosine of pi. And now the cosine of 3 pi over 4, that's 135 degrees. That's 45 degrees off of the negative x-axis. And so the cosine is negative in that second quadrant, and the value is negative root 2 over 2. And then minus the cosine of pi is -1. So even though we switched out the negative sign there, we still end up with negatives. If we would have left this in, then we would have 2 more negatives. So we would have had 5, and it would be a real mess. This is already messy enough. Negative square root of 2 over 2 plus 1. So 2 minus the square root of 2 over 2. And one last example. Let's consider the integral from 0 to 1 of e to the negative 3x dx. What is the antiderivative here? One guess would be e to the negative 3x, but if you take the derivative of e to the negative 3x, you get e to the negative 3x times an unwanted negative 3. We're not interested in this negative 3 times e to the negative 3x. We want our derivative to simply be 1 times e to the negative 3x. And so we can modify this to get rid of the negative 3. If we were to consider the function negative 1/3 times e to the negative 3x, its derivative then would simply be e to the negative 3x. The negative 1/3 would multiply the negative 3 to give 1. Now this antiderivative could also have been accomplished using a u substitution, with u equals negative 3x and du equals negative 3 dx. But for such a minor modification of a standard function e to the x, it's nicer to just guess at the answer and then fix it. So now, the next step, I guess I want to get rid of that negative again. 1/3 e to the negative 3x, and then switch the numbers. 1 on the bottom, 0 on the top. So plug in 0. E to the 0 is 1, so that gives us 1/3. Minus plug in 1, and that gives us 1/3 e to the negative 3. If we want, we can factor out that 1/3 and make it look a little bit nice. 1 minus 1 over e cubed. E to the negative 3 means 1 over e cubed. So we can write our answer computations of definite integrals using the fundamental theorem of calculus. Thank you for watching.